Okay, so first we talked about big data, then we talked about all the components of Hadoop, and then we talked about HDFS. In HDFS, we basically concluded that we require Hadoop distributed file system in order to store humongous data. And then afterwards, we will discuss how do you process such kind of data. Such kind of data which is in terabytes and is stored on a distributed file system such as HDFS. We built a storage which can store petabytes of data without having to worry about anything. You just have to keep on adding devices and hardware and you will keep on increasing the storage ability. Okay, so that was HDFS introduction we did on the previous session. As discussed on the last session, I will do a quick recap of Linux, and that's a very important aspect of using the cloud labs. Okay, so first of all, everybody must have logged in into. Okay, all right. So you will see your login and the password here. Okay, so first of all, you open the console. All right, and then we copy the login, paste the login. Okay, then copy the password and paste the password. When you type or paste the password here, you won't see any asterisk character or any other character. Okay, so when we talk about Unix, the most important part is a console. There are two ways to log into this console. Right now, this console we are running in the browser. Same thing I could also do from the command prompt. Okay, so this is my command prompt. Let me close everything and then start again. So we have a terminal on. We have a terminal on. What do you say? We have a terminal on Mac. Okay. If you are on Mac, you can press command spacebar and type for search for terminal, and you will find it. Okay. Now on Windows, if you are on Windows and you want to log in, in from the Windows and you don't like the browser interface. Okay. Ideally, you would not require anything else. Okay. So to open the console of this machine, you will either need this web console or you can directly use a command called SSH or a application which you can install on Windows called PuTTY. Okay, so you could say SSH and then my login ID. My login ID is Sandeep at h5.cloudxlab.com. Okay, I have to remove HTTP and all of this. Okay, so I'm trying to show you that you can either log in using command line or you can directly log in using the browser. I prefer the browser one. Okay, now you can see I've logged in here as well. Okay, so I'm logged in via console and I'm logged in via SSH. Okay, so either using the browser or using the console using SSH, or in case of Windows you could use PuTTY and then log in. First of all, here we are going to talk about Linux, Unix and all. They share the same basic principles and same terminology of everything. Okay, so we are going to work on Unix. So first of all, we open the terminal, which means, what does it mean by this terminal? Here, if you run any command, you are running the command on this machine, which is located in New York. Okay, so basically, I am kind of transported to New York, whereby I'm typing any command and my command is being executed on that machine. Okay, so this is very important because here, instead of bringing data to me, I am being transported there. Okay, so this is the command prompt from which the whole process starts. Okay, command prompt. This command prompt is also called shell. This is also called shell. SHELL. Okay. Uh, okay. So this is also called shell and also called command prompt in the Windows. And why do we need to work on this when there are so many graphical interfaces available? Why do we need to work on this? Let's understand this. Okay, so first, when we churn any data, we have to use many utilities, many automated systems. In those cases, command prompt is very powerful. As you will see when we do Hadoop streaming, that the command prompt is actually very powerful. Okay, you will notice that almost everything we could get through command prompt. So there are two ways to do. One is you are given a user interface and you are clicking with the mouse and getting the things done. Okay, this sounds, that one is very easy to learn, very easy to operate, but very difficult to automate. Telling the program that click on a window at this particular location is a very difficult thing. Okay, therefore using the commands is a very quick way to automate a lot of things. Okay, so that's the first thing to understand. Second is that this command prompt, anything you do here, you are executing that on h5.cloudxlab.com, and everybody is in their own account, so you are not going to disrupt other people's work. Okay, now let's jump in. So we are clear, right? That why do we need command prompt? Because it's easy to automate using command prompt. Okay, and you don't require high bandwidth to operate on command prompt. All right, so this is something very important. In case of Ubuntu or Linux, everything is a file. Everything is a file. Mouse connected to the machine is a file. If you are trying to talk to mouse, you can read that file and you are reading the data from the file. Okay, and what is a file system? File system is a kind of way of organizing your data in which there are folders. So there is a default top level folder. The name of that folder is slash. Okay, the name of that folder is slash. Everybody is the children of that folder. Inside a folder, you can create more and more folders, and inside the folders, you can create files, or you can write your programs, you can upload your data, and so on. Okay, and in case you want to upload some data to here, so this is our Linux system. When you say pwd, you know your current working directory. Right now, I am in my home directory called /home/sandeepgiri 9034. Okay, and I say ls means show me the listing of all the files in this folder. Okay, ls shows all the files in this folder. All right, and rm deletes a file. Say for example, I'm trying to delete this particular file. Okay, so I could just say rm space pig and all right, so it has deleted that particular file. Let's say I want to delete all the files starting with pig underscore and ending with log. So I could say pig underscore asterisk dot log, which means I'm using a wildcard asterisk. It's not regular expression, but I'm just using a wildcard called asterisk. Okay, so now all the files starting with big underscore and ending with dot log have been deleted. Okay, now under this, this is my home directory. Okay, you can see I am inside two label, home and then Sandeep Giri. You see that? Home underscore and then Sandeep Giri. If I say, okay, first of all, to change your directory, you could say cd. Okay, so let's say, and to see whether to see the details of the file, instead of saying ls, you could say ls minus l. All right, one step further and one step back. So we try to show you how to interact with the file system. Okay, so the only command we have used is ls and rm so far. Okay, so if you want to create your own directory, you could create, say, make directory 6fab. It says file already exists. Okay, so what should we do? We call it 6fab hdp. Okay, 6fab hpd. And so here you will see, if you say ls minus l, you want to see the details of the directory. You will see the details in this manner, where the first column is the permissions on this file. Okay, permissions we will discuss later. Then the owner of the file and the group of this file or folder. Okay, so 6fab is a file, while 6fab hpd is a directory. You can see D here, it means it's a directory. Okay, so we have just created a directory called 6fab hpd. Okay, inside this we can keep storing the data. Okay, all right, so basically whatever we are doing here, it's writing the data on the disk. Okay, so that even if the system reboots, this is going to be available again if the data is not corrupted. Also, whatever we are doing right now, we are doing on the machine, a local machine, a machine called H1 H5. It's not on HDFS, it is on H5. h5.cloudxlab.com is a computer just like mine and yours. Okay, and on this we are logged in from remote and working on this. All right, it has no special hardware, it has actually very reasonable hardware. Okay, so we are connected to this and we are working on this machine. Now let's say we want to change directory back. So we first, what we did cd and this folder called 6fab hpd, right? If you want to go up, we say cd and then say dot dot. Dot dot means above directory. Okay, and cd dot means current directory, which means it has no effect at all on cd. Cd means change directory. Cd directory name. If the directory name is dot dot, it means you're talking about the parent, so it goes up. All right, if you want to see my present working directory, it is this. If I go one more level up and the pwd, I am in the home directory. Earlier I was here. Before that I was inside 6fab, which is inside this, and then I've gone one level up. Now if I go one more level up, I will hit the root. Okay, you see my present working directory pwd, its present working directory. It shows that my current present working directory is slash. If I keep on doing this, it has no impact at all because I have reached the top level. Okay, I'm not going anywhere above this. All right, so I can't go above the present working directory. Perfect. Now here we are typing these commands, and what are these commands? Again, all of these commands are basically a file. You don't believe me? To find out where is this location, we say which ls. it says that ls is an alias and it is pointing to bin/ls. Okay, now we can say ls minus l and provide the name of this file called bin/ls, and you can see that it's a file. Okay, you can see it's a file with the following permissions. Okay, if you delete this file, nobody will be able to do ls on this machine. All right, so now we said ls so far. We could also say /bin/ls. Correct? This is the absolute location while calling a program. Or we could say dot dot slash dot dot and then bin and ls. All these three things mean the same thing. How? When we say ls, this command prompt will look into a variable. There is something called environment variable. Okay, it will look into the directory called bin/bin directory that's defined as part of that variable. And so when you say ls, it's going to find out in the path where is this file located and will locate it by itself. Now, so either we could say ls or we could say /bin/ls in case we know exactly where our ls command exists. So, and this ls is nothing but a program. Like me and you can also create such program, and we will create such programs which we can be executed. Second, this bin/ls is absolute path location of ls. All right, or the most important part is that the file which you are trying to execute should have x here. It should have x. Okay, it should be in the executable mode. All right, so this is where we are now. The second format is very important. Whenever you refer to a file, you can also refer like parent/parent slash means inside parent go to this folder. Okay, so we say the way we have said, go to the root, then go to a directory called bin and then go to ls. All right, so the way we executed ls command was either type ls, type bin/ls, type dot dot slash dot dot um, dot dot slash dot dot slash dot dot slash bin slash ls. Okay, because extra dot dot does not have effect if you have already hit the root. Or you could go up again, you could go up. Now you see here it shows that you are at slash. Under that you could go bin. Now our present working directory is slash bin. Here we could say dot slash ls. Sounds good? So this is the way you refer to any file. So we always refer to a file using either the absolute path or the relative path. All right. So this is our command prompt. This is where we will be interacting with Hadoop. Okay. I prefer the command line way, though we have other viewers such as you, which provide you a UI with which you don't have to type the commands. Okay. But I prefer this way sometimes because it gives us a little more control. Alright, so till now we have only talked about local file system. Okay, along with this, you are also given Hadoop file system. And as we talked earlier, Hadoop file system is singular. Okay, a file system which has many multiple machines to store data on, but there is a single name node. Okay, so right now we have h1.cloudxlab.com, which is the name node, and right now we are logged in onto h5.cloudxlab.com, which is one of the data nodes as well. Okay, so far today whatever we have discussed about ls and every command, we only talked about local file system. Now, in case you want to interact with HDFS, the way you do is you say Hadoop and FS. It will show you all possible commands you can you can execute on the HDFS. So you could say HDFS minus ls. What does ls do? You can see that it has these parameters. Okay. Also, you can say minus help and ls. It shows you that minus ls command. So the way to interact with HDFS is a Unix command called Hadoop FS. This needs to be installed. Okay, but we have already installed on the cloud, so we have all of this available for all of you. Okay, so we have Hadoop FS minus help, and if you do not type any help or anything, it'll give you the list of all the files, all the options on this. Okay, so getting back to it. So the way you execute, anyway, let me just close all of this so that we are no longer confused. Good. Now going back to my web terminal. All right. So we talked about how to execute commands, and on every command like ls, we can provide arguments. These are arguments which are given to your program. You remember, if you had worked on C or Java or anything, every program is supposed to have a main function, and in that main function you have arguments. These are those arguments. We are providing various kinds of switches or options or arguments on the command line after ls. Okay, so we can, if you want to convey more things to ls, we can provide those on the command prompt. Okay, if you want to see what are the options available on ls, we could say minus help. Okay, you can see that you can, all the details about this is available. Also, you can say man ls or man any command for finding out more information about ls. So every command is a file which is in executable mode. You can call it by either putting that name in the environment variable called path, okay, or you can call it by the way of absolute path or relative path. If you don't want to call a program by absolute name or relative name, you can call it, if you can put that folder in your path by saying export path equals to $path, and then you can put the name of the folder. Right now I'm saying dot. Okay, that means my current folder is a part of my path, which means anywhere I am, if I want to execute some program from here, let's say mycmd.sh, this is one program I have created, so it has been launched. If we do not provide that, we should tell /mycmd.sh, which is the relative path from the current directory. Okay, so relative path and absolute path are very important, and most of the programs you can call by using this. All right. Similarly, on the same lines, we always talk about Hadoop. We just showed you a command called Hadoop FS. Now this Hadoop is also a file. How do you find where is it located? Use a program called which basically tells where is this file located. Now we can check by using ls minus l and providing an argument that what is this file about. It shows us that it's a link. It's a link. Bin Hadoop is a link pointing to this big URL. Now, if I have to find out what is this URL, it shows that it's a file actually. Okay, now what is inside this file? Either we can start editing this file or use a very magical command called file. This command called file is very magical. It basically tries to understand what is there inside the program. Okay, it tries to understand from few bytes from the file and tries to decipher whether it's a binary program, it's a plain text, it's a SQL, or it's a Python, or it's C. Okay, so it has showed that it's a Bourne shell script. Okay, now similarly, if I say my cmd.sh, now it'll tell it's a shell command. It's not trying to guess it based on the suffix. Let's say I change widget.java's name to simply widgets. Okay, widgets, let's say J, I'm writing its name. Now even if now you can see it has, okay, and yes, all right, it is saying that it's ASCII text. It's not Java. Let me, okay, so actually it's not, it's thinking that this Java program is not a proper program. Okay, let's just see what is there inside it. Okay, it shows that it has very long line. So basically, like my hello.py, let's see what it says. It says that it's a Python script. You can see that it's a Python script. All right, so that's the magic thing about this file command. It can tell you exactly what is there inside a file. All right, these are the few tricks I could tell you. So we found out that what is our Hadoop command. We first use which. Okay, similarly, we can also find which Java are we using. It says, okay, your Java command is located here. We can see more details about this. It says that it's pointing to some other folder. Okay, then we go to that folder. Oh, this is again pointing to some other folder. All right, we say ls minus ls and jre bin java. Okay, it says that this is a proper one. Now this one we can use file command, and it says that it's a 64-bit LSB executable. It's a binary file. All right, so that's a magic thing about file command. It tells you what is there on a machine. All right, if you want to see what processes are running, so whenever you execute a command, it starts a program. This program, this program might be a long running process, or it might be a short running process. Okay, but every program starts whenever you execute a command. Here on the prompt, it starts a program. What is a program? A file loaded into the memory and instructions being executed as mentioned in the file. Okay, so we tell the computer that, hey, my program is located in this file called ls. Okay, and please execute this ls. And this ls will do the job of finding all the folders in the current working directory and give you the list. Good. Now, moving ahead. So we talked about what is a process and how does it work. So when you start a process by executing a command, you can see that it will come in the PS, or it will come in something called PS tree. Okay, PS tree shows the whole structure of processes. This is not directory. These are processes. A process is again a kind of, say for example, I'm logged in right now. If I start a command, it is going to start a process which will be the child command of this command prompt. Okay, you can see, I'll show you ps minus u, and I'm saying that explicitly only show me the ps tree of only this user. It says that the parent process is bash and child process is ps3. Why? Because ps3 itself is a command. Okay, so it shows that the bash is my shell. This place where I'm standing right now is running a process. Okay, this process is listening to my commands and I'm typing those commands. And therefore it says that bash is bourne shell, and this is basically a program which listens to my commands and executes those commands on the Unix. All right. So when you connect over SSH, you are basically given, you are uh, on your behalf, it executes a program called bash, which listens to your commands and executes them. And when I executed PS3, PS3 was basically a child process of a process called bash. And both these processes, bash and PS3, are owned by me. They are they represent my user ID. Anything they do, if they create a file, if they delete a file, anything they do, they are doing on my behalf. They cannot suddenly become root or somebody else so easily. Okay, though they can become sometimes. Now processes again um, execute in the memory of the computer. When you run a program, when you type a command, what is actually happening? It reads the instructions from that command and loads it into the memory and then does the other work. All right. So now we talked briefly about Hadoop command. Hadoop is also another command. Okay. Hadoop provides you many argument. You can see fs version jar. Let's check what is the version of Hadoop we are using. All right, it shows that we are using Hadoop 2.7. Okay, now next is that's our Hadoop version command. Then Hadoop fs command provides us with interaction with HDFS. All right. So the first and foremost command is -ls. -ls shows the listing of my data in my HDFS folder. HDFS also provides everybody a home directory. This is your home directory, just like our local home directory. Now, let me first describe these permissions. I think it's very important to describe the permission. All right. Let me first describe the permission on the local folder. When I say ls-l, it shows us who created the file, okay, and who are these users. All right. Now, this section is the permission of the file, and this is the username. I mean, the user who created the file, the owner. We call it owner. And this guy is called as group. Okay, this is the name of the file. This is the name of the file. This is the size. This is size. Okay, this is the size. And this is the name of the group. Sounds interesting? All right, and this is the time at which the file was modified. So every file has these. Right now I'm talking about classic Unix file system, and as a matter of fact, all the file system, whether Windows or everybody, has a similar kind of model where you have a file name, and then you have owner, and then you have group, and you have others. All right. Now, what does these permissions mean? These permissions, as you see them here, okay, let me try to paste it. So these permissions are basically made up of three parts. Okay, so dash means not allowed. Okay, while, okay, here what does it say? It has three parts. So the first one is the kind of either directory or file or link, etc. So the first character means access. Okay, dash means it is a file. This guy is the owner, this guy is the group, and this guy the other. So what does it means that group and others. Okay, it means that owner can do these things, RWX, group can only do R and X, others can do R and X. What does it mean? Means owner can read the file. Who is owner? Sandeep Giri 9034. All the people whose there will be only one user ID. The user ID Sandeep Giri is allowed to read, write, and execute this file. It means the owner of this file called Sandeep Giri 9034 is allowed to read, write, and execute. What does it mean by writing? It means he's allowed to delete this file, edit this file, and read this file. Okay, as well as he's allowed to run this program. Had it been, it's an executable file. Okay, it's an executable file, therefore user can execute it. Although while running it might say we could not find a way to execute this program, this doesn't look like a program. That's another issue, but permissioning is allowing the user to execute the file. Okay, now group, meaning the people who are part of this group, people who are part of this group can execute, read, and the file, but the group members are not allowed to modify this file. Okay, similarly other people who are neither having this user ID nor are the members of this group, okay, they are only allowed to read and write this file. If let's say I decided that I create a folder for this 6th February batch, all I will do is I will create a Unix group for all of you and then add all of you into that group. Next thing I will do is create a directory on which I change the group of this file to that group which I've created, so that all of you will be able to access the file but others won't be. Okay, so that is the magic, that's the magic of these permissions. Okay, now how do you change the owner, change the group, and change the permissions? You use the commands. For changing the owner you use change owner. To change the group you use ch group command, and to change the permissions you use chmod. Okay, so these are the basics of, you should go through chown, chgroup, and chmod. That'll be simple for you. Okay, so these are the basics of Unix permissioning. And interestingly, same permissions are also same definition of permissioning is also applicable to HDFS. Just that you will have to create the user in HDFS with the same name, same login as the current user, current local user. All right. So if I right now, let's say there is this directory I'm standing in, and what I do is I allow you. Okay, I say 6fab, for example. What was 6fab having? It is having just some data. This is my data. I check the file, what is there inside this data. It says it's everybody can read it. Are you able to read it from my folder? Are you able to say cd/home/ this folder? Are you able to do? And if you want to see what is there inside a file, you can use a command called nano, and you can edit the file. Okay, using nano command you can open the editor. Although there are many editors including vi, but nano seems to be the most user friendly, therefore I'm talking about nano. Okay, so this is a good cheat sheet you can try. Okay, and try to learn. If you want more details about any of these commands, you can simply come to the console and say man and that command. Okay, you can press Q here to exit. Okay, so you can learn more about each of these commands from this website. All right, so a little more on the Unix command line side. Okay, so right now we talked about how to execute a command, how to provide various arguments to it. What if we have to pass the output of one command to another? All right, so let's first understand that there is a command called WC. What does WC? WC does a very simple job. It basically does the word counting. We say this something and this, and when I end it, how do we end it? Press Control D. As soon as you press Control D, it prints number of lines, number of words, and number of characters. So WC takes the input from the user and then counts the number of lines and words and characters and prints onto the screen. All right. Now we talked about two things: ls, which lists the files, and wc. WC, anything you type in, it basically counts number of characters, number of words, and number of lines. All right. Now let's say you want to count number of characters, number of words, and number of letters in the ls output, meaning the data given to you by ls, you want to give it to wc. Okay, you want to give it to wc. All right, one way could be that you save this data inside a file. Okay, how do you save some data inside a file? By putting the arrow like this, and we can say my list. Now inside my list, all the output of ls has gone. You can see that all the output of ls has gone into this file. It's a file that contains the output of ls. Did you notice this? Now, okay, now we could say wc my list, and it has counted number of characters inside my list, number of words, and number of lines. But this is too clumsy. For every program, we are passing, first creating the file, and then we are passing that file to another one, and so on. What if ls and wc we could stitch together? We could say ls and then pipe and wc. Now here is the magic that happens. The output of ls starts going into wc. The output of ls command starts going into wc. And you see the magic? It does the counting for you instantaneously. Furthermore, please note, furthermore, you can pipe the output like this. And you can keep on doing it again and again. All right. So basically the output of ls went to wc. Wc counted the number of characters, words in the output of ls. Similarly, the output of wc, which is this, went to another wc, and you can see it has counted 24 characters. From the beginning, it's counting the spaces as well, and therefore it's saying there are 24 characters, 3 words, and a single line. So that's pretty much about piping. So any program which takes the input from you, okay, any program which takes the input from you can take the input from another program. Similarly, let's say you're executing a command called grab Sandeep. It's going to find only the lines which contain the word called Sandeep. Now, if I say Sandeep Giri and I say Leela, in case of Leela, it did not print anything. Instead, while in case of Sandeep Giri, it printed something. All right. So you could pipe the output of ls, okay, to grab. Grep is a command which looks for a word in the input and then print only those lines which contain the particular word. Let's say I said grep x, it has only printed the lines, it has only printed the lines which contain the letter x. Okay? So that's the magic about the piping. The output of ls went into grep and grep did something. Now, we could do some more thing. We could say grep a, and you can see the a is contained in so many words. Now we can take a one step further, pipe the output of grep into sort. It sorted the data. You can see that it has sorted the data. All right. And you could further go ahead and say unique. Unique basically finds the unique words in it finds the unique words in the data which is ordered. If the data is not sorted, unique does not work. All right. So here right now all files are unique. Therefore, there is not much of a difference. Okay, so this is a quick case of sorting, piping. So we pipe the data output of ls to grep, where only those lines that contain a were printed out, and then we pipe the output of this this pipeline, the current pipeline, to sort, which sorted the data, and then we passed it to unique. Okay, and we could also have done WC. So you could rearrange these pipelines and create really, really complex systems. And that is the wonderful thing about Unix. This is the powerful thing about Unix. And you will see further that we will exploit all of these commands to run MapReduce and to do MapReduce in a single shot rather than writing a lot of code. Okay, you will see all of this. How do we do word count in using Hadoop streaming using command cells? All right, so moving on, let me now talk about HDFS. Okay, so what we will do is we will first upload a file. First create a local file. Let me just create a local file. I'm creating a local file called 6fab hdfs file.txt. I'm using nano editor. I'm typing, say this is my data and this is really, really secret. Okay, and I'm control X and Y and enter. Now this data is saved. Okay, now let's upload this file into my home folder in HDFS. Okay, let's first check what is there in my home folder in HDFS. I'm saying Hadoop FS minus ls. So this one talks to HDFS, which is the name node, and gets me the list. Okay, and keep in mind that when I say Hadoop FS minus ls, it's going to only talk to the name node. All right, now let's say I want to upload a file, the recently created file. We say copy from local. I'm copying the data from my local folder and uploading it, okay, uploading into my home folder in HDFS. Since I have not provided a destination in this, it will copy this local file into my home folder in HDFS. Okay, so right now we are interacting with HDFS using our from our H5. Okay, if we log in into H6 or H4, if we log in into H4, still the we will be able to talk to the HDFS in the same manner because name node is same for all. Name node for H4, H1, H2, H3, H4, H5. for everyone, name node is same. Therefore, if you want to upload a file into HDFS, it's going to be the same folder everywhere. All right, let me just show you that even if you log in from Hue is running on H4, and Hue is a web-based interface to talk to Hadoop. So Hue internally is making a call to Hadoop FS. Okay, and you can see that the file has been uploaded here. My home directory in case of HDFS is this, while in the local folder it was this. It was /home/this. Okay, now you could see, let me sort the data by date. You could see that this file has been created. All right, now after uploading the file, I deleted my local file and I want to see what is there in the file on the web, on the HDFS. So I say Hadoop fs -cat. All right. Now let us say this command Hadoop fs -cat, this, it talked to name node or only data node or both. Did it talk to name node, data node, or both? So I'm saying Hadoop fs -cat and file name. So I'm trying to get the data, what is inside the file. So will it talk to name node, data node, or both? It will talk to both. So this Hadoop fs -cat command, it's going to talk to name node first and say, hey, can you tell me where are the blocks of this file located? And then name node will tell you, you go to h1.cloudxlab as well as you could go to h2.cloudxlab and get the data. Okay, so this command is going to talk to both of them. And how many blocks are there? It is going to have one block and three replica. Okay, three replication factor. And how do you find out about the replication factor? It's listed here. I will show you. I will show you that when we did this, okay, when we do ls, it shows the replication factor in case in here. You see 3 here? This is the replication factor. Do you see 3 here? This is the replication factor. Okay, which means there are 3 machines having the block dedicated to this one. Okay, you could use HDFS FSCK command to find out about the file. Okay, okay, so it shows us, okay, we are using this command called HDFS FSCK here. It says that connecting to the name node via this, okay, and these are the commands that get executed. You can check this. This is basically h1. Okay, this is basically h1. We are saying that you are connected to the host like this, and there is one block with a replication factor of 3. The length of the block is 46 bytes. Okay, and these 3 replicas are located on these IP addresses. These are the local IP addresses of H1, H2, H3, H4, and H5. Local IP address, so that these machines have 2 IP addresses. One local, so that they can talk to each other, and one public, so that people like us can talk to them. So they have 2 network interfaces, therefore 2 IP addresses. So you can see that, and then here it shows that the status of this file is healthy because the minimally replicated blocks are 100%. Okay, similarly here the average block replication is 3. All right, now we could do something crazy as setting the replication factor to say 6. While we have only 5 data nodes, we are setting the replication factor as 6. Okay, so the replication factor has been set to 6. Now let's check the HDFS block location again about this file. What happens now? Okay, it says that same thing here. Here it says under replicated. Okay, under replicated. It says that the target replicas is 6, but we have found only 5 replicas. Okay, the reason is that we are forcing it to create 6 replicas and we have only 5 machines. Okay, so right now it's trying to do as much as it can. There are 5. It has basically created 5 replication factor. It is not able to create. It has not able to go beyond replication factor as 5. Okay, so now you can see that the average block replication is 5. It's not going beyond that. Okay, we could take it back to say 2. We have set the replication factor as 2, and let's see what happens now. Okay, it says that replication factor is 2, but still it's having so many copies. After some time it will delete some of these. Okay, it has deleted some of the copies, and now you can see the total number of replicas is only 2. Okay, so question is, where is my data? In case there is a 10 node cluster where we know, okay, so the blocks, in case there is a 10, where would you know each replication is stored? That you can see in this, that you can see here. While you say while you execute this command, okay, HDFS FSCK blocks. Okay, when you execute this command, you will see the IP addresses. It shows that from here the IP address and the port number. All right. Okay. All right. In case you are wondering where are these blocks stored on data nodes, okay, you could go to slash what was that? What was that? Slash Hadoop and slash HDFS slash data. This is where data node process is storing its data. You can see this is the place. You can see BLK. It means it's a directory. It's a block file. It's a block file which contains the data. For every file, you can see something is happening. This is somebody's block I'm fiddling with. Okay, so basically you could check that every information is here. All right, so on every data node it stores data in this folder. You can see that inside Hadoop HDFS data, this is where the files are being cut into pieces and stored. All right, so the one part which we did earlier was this, where we said Hadoop fs minus copy from local, and we provided our local files, local folders name. Okay, ouch, I am in the wrong directory. I need to go to my home directory. Okay, I'm saying Hadoop fs minus copy from local, and I could upload any file I want. Alright, let's say I want to upload stocks.zip. This is how. Alright, is that right, Anian? I'm saying Hadoop fs minus this. Alright, now let's say there is some file on your desktop. Okay, there's some file on your desktop and you want to upload that into HDFS. There are two ways to do it. Either either you first copy that file from your desktop using SCP or WinSCP into H5, and then once that finishes, then you upload to using copy from local. Or you could simply upload it here, upload from here. Okay, you could simply upload here and say, actually, I do not have something uh, which I can just upload. Alright, also everyone, do not upload things which are important to you or confidential in nature, because our sysadmins keep on reviewing the folders, okay? And since it is supposed to be for educational, we do not expect that you will be storing your confidential data here. Alright? So we just now uploaded a file into Hue. From here, we can download to our local directory. Local directory as in the H5. Let's say we want some file in the local directory. Okay. Let's say, which file do you want in the local directory? Let's say this file. Say test.data. We want to copy this to my local folder, which is h5 h5.cloudxlab. Copy to local test.data. Okay, so we have got test.data. Okay, so we talked about minus copy to local. So you must try these commands for sure. Okay. All right. So this was our introduction to Web Console, Hue, and Ambari. There is nothing much to do because everything has been taken care. Also, the installation instructions you should go through in case you really want to install virtual machine, you can use it. Okay. All right. So that was pretty much about hands-on with respect to the HDFS. So now should we start with the computer engine? A basic introduction. So what we discussed so far is that whatever file we upload in HDFS is distributed on many machines. Okay, so a single file is capped on many machines by slicing into blocks, and every block replicated on many machines. Okay, so effectively parts of the data is available in the network, right? That's what we discussed as part of our HDFS. Now let's talk about compute engine. A quick teaser. How fast can 1 gigahertz processor sort 1 terabyte data? How much time will it take to sort 1 terabyte data? And 1 terabyte data is how much? 10 billion names having 100 characters each. And the RAM you are having is 2 gigabyte. Alright? Honestly, the way I have done it in past, that I have broken the file into 2 gigabyte each, which means 1 terabyte data became 500 files. Okay, 1 terabyte data became 500 files. Then I individually loaded that 2 GB file and then sorted 2 GB file individually and then merged it. Merging sorted data is easier than merging unsorted data. Okay, so all right, so the way I did it was I broke the file into 500 parts and individually sorted 500 parts. Sorted means ordering the data. Okay, sorting means ordering the data. So I basically sliced these 10 billion names into into 500 different files, such that such that each file is having only 20 million names. Each file is having only 20 million names. Okay, and then I sorted those 20 million names individually and then merged them together. A question from everybody is that how does, if you're merging them again, isn't it the same effort? The answer is no. So, merging sorted data to produce sorted output is far more easier. Let's take let's take this simple case. Simple case is Simple case is that you have 10, 12, 13, 15. Okay, this is one set of data that need to be merged with 14, 14, 15, and 16. Okay, let's say you're trying to merge these two data sets which are individually sorted. We have sorted the first set and you have sorted the second one. You want to merge them together. All you need to do is stand in front of both the queues. Imagine that these are the two queues and you're standing here in front of them, both the queues. Pick up the heads of the queues. Whichever is smaller, you put them in the output. Okay, here these were both of the same value. Now it compared these two. Which one is smaller out of 12 and 14? So we are merging two lists which are already sorted. Okay, you just pick one of these, whichever is smaller. Now again, who is smaller out of this? This time, who is smaller? 14, 14 and this. Okay, so we get 14 out of it. And then out of these two, we again pick 15 and then 16. Alright, so what did I do just now? I quickly merged two lists so easily. Similarly, here also, what I did was I first broke the file into 2 GB each and then read each one, sorted each one independently, and then merged these files such that the output is sorted. Okay? Alright, so approximately for doing all of this magic, it'll take minimum of 10 hours. It might take 6 hours in case you have a really good processor, good hard disk, good RAM, but on an average, it would take around 10 hours. Or maybe more than 10 hours. So basically, what I wanted to show you is that when we talk about 1 TB, it sounds like so because 1 TB hard disk is available in the market for 3 to 4,000 rupees. And probably everybody is holding a content, maybe movies, TV series, and songs, and everything combined together comes around to 1 TB already. So 1 TB sounds like small data, and our gut feelings so far have always said that when we sort data, when we do anything with the computer, it is actually fast. So we get a feeling that anything we do on the data is pretty fast. But in reality, it is not. Okay, you could imagine again that this same data was in your database, and there is only a single column in your table, and all of this data, all of this 1 terabyte data is on that single column. The table has got 1 billion rows. If your table has got 1 billion rows and you are supposed to create an index, do you know about index? Index is something like, you create, index means it will internally create sort of the way on the back side of the book you have the index of the words, right? That which words are sorted, words are ordered, and everywhere against each word it mentions that where did it find the word in the book. So it's exactly same way database also prepares an index so that when people come looking for a particular keyword, it can quickly jump to that location. All right, so indexing is nothing but ordering the data. So even if you have really brilliant database in which you have stored 1 terabyte data in a single table, it's going to take 10 hours time to create an index on it, while in your career at most the index creation might have taken at most 10 minutes. In my career, I have never seen the indexing process going beyond 10 minutes because I never indexed data so huge. So if if you try to even index 1 terabyte data, it is going to take maybe 10 hours. All right, because sorting process is is basically going to read and write a lot of data. And why is it so? Why is it so? It's not because our processor is the bottleneck. It's not because our computer is slower. Okay, the problem is that this 1 terabyte data has to be read from the disk, and while cutting it into 2 gigabytes we have to write it back into the same disk. So this whole process of reading, writing the data from the disk is going to take humongous time. While sorting the individual piece is quite a standardized way. You can't go smaller on that. Okay? So basically, these are the reasons why sorting 1 terabyte data is a big deal. Now, what we need is sometimes we might need to solve this problem really fast. Let's say I want to sort 1 terabyte data every 2 hours. Second, I might have more than 1 terabyte data. Okay, also I might have to do it very often. So the current software is not solving our problem. The current mechanisms are not solving our problem of ordering 1 terabyte data. Therefore, therefore, we need a better system to do the sorting. And that's what is MapReduce about. Why? How can we do this? Algorithms are not the bottleneck. It is the read-write speed of the disk as well as CPU and RAM is the bottleneck. Because algorithms theoretically cannot sort faster than the available algorithm. Available algorithms have been proven very well that they do a great job. You cannot have a newer algorithm of sorting which is considerably faster than the existing one. That's the theory as of now. Okay, so then how do you solve this thing? How can we make it faster? By using many computers. Google was a part of a challenge called sorting benchmarks. And sorting benchmarks is a very important challenge for all technology company. This is where everybody chest thump about their ability to do the sorting. And Google in 2011 won it by a very big margin. Okay, they were able to do sorting of 10 petabyte data. 10 petabyte data in 6.5 hours on 8,000 computers. Using 8,000 computers, they sorted 10,000 times the data I was trying to do, and they did it in 6.5 hours. And that was in 2011. And how did they do it? Using MapReduce. Okay, using MapReduce. All right. So this is where the core concept of MapReduce come in. We'll discuss in depth how to do the MapReduce. We'll do hands-on, and we will try to go back and forth and try to find out what are the alternatives, what is the something wrong with the alternatives. And that exercise, trust me, that exercise of trying out other solutions instead of only Hadoop will give you a conceptual clarity, and you will understand the difference between how Spark does and how MapReduce does. All right.